So this problem states that 10 kilograms of R134A at 300 kilopascals fills a rigid container whose volume is 14 liters. We have to determine the temperature of total enthalpy in the container, and the container is now heated until the pressure is now 600 kilopascals, and we have to determine the temperature and total enthalpy when the heating is completed. So this is our diagram. Calculate our specific volume 1. We have to convert it to the liters to cubic meters and over our mass to have cubic meters time over the seconds. So we have the 14 liters, and in 1 cubic meter we have 1000 liters. And this over our mass, that is 10 kilograms. This equals our 0.0014 cubic meters over seconds. So in this case we have to calculate with our tables our specific volume, final and our specific volume F and G. So in the table A12 we have our data, but we do not have this data in 300 kilopascals, so we have to interpolate. So for FG we have 280 kilopascals and 320. So we have 280 and 320. So we want the 300, and for 280 we have that FBF is 0.007697, and for V320 we have 0.000661. So we have to calculate this, and our formula is x minus x1 over our x2 minus x1 equals our y minus y1 over y2 minus y1. So this data we have to substitute in these ones. This is our x1, our x, x2, our y1, y2. So we have that 280, 320 minus x1, x1 is 280. This equals our y minus our y1, that is this number. So it's 0.0007697 over our y2, that is 0.00067 minus our y1. So we should be looking for this one. So our y, it's y is So this gives us 0.000734 cubic meters over kilograms. So we have to do the same for our BG. We look it for in the tables for the values, and in the tables we have that for 280 our BG is 0.072434, and for 320 it's 0.063681. So we have to look for our 300. We have to look for our 8y, and our formula is this one. So we have that this is x1, this is x, this is x2, this is y1, y, and y2. So we have that it's 300 minus 208 over our 320 minus 280, and y minus our y1, that is 0.072434, our y2, that is 0.063681, minus this one, that is 0.072434. So this is our BF, and our BG equals so it is equals 300 minus 280 or 320. So this equals our 6.057 cubic meters over kilogram. So now we have that our B and our BF and our BG. So we have to compare these values. So this value is in between these two. So if our B is in between BF and BG, this tells us that it's a mixture. So we have to calculate our x. So in this case, our x is our B minus BF over BFG. So in this case, our B is this one, and our BF is this one. So our x equals 0.0014 minus 0.000773 minus it's this one minus this one, so it's 0.068057 minus 0.00070. So our x equals so this equals 0.00919318. So now we have to calculate the temperature for this case. So the temperature, because we don't have the exact value, we should interpolate with this value. So for the temperature, we have that for 280 in the table A12. The temperature, the Tsat, is minus 1.25. We have to look for 300, and for 320 we have that. So this equals our y minus our y1, which is minus 1.25, over our y2, that is 2.46, minus our y1, which is 1.25. So our y, which is a Tsat, equals so this equals 0.605. So this is for part 1, and we have, with this x, we can calculate the enthalpy. So the enthalpy is, the formula is H equals HF plus Rx times the HFG. So we don't have these values with 300 kilopascals, so we have to interpolate. So I will do it in here. So for HF, we have the same. We have to calculate the y. So we have 280, 300, and 320. So in the table A12, we have that the HF for 280 equals 50.16, and for 320 equals 55.40. So we have this to do the same procedure. And for HG, for 280, our HG in tables A12 equals 249.77, 249.77. For 300, we don't know, and for 320 equal 251.93. So we have to do the same, and our FG, HF in this one equals 300 minus 208 times the 50, 40 minus plus 15. So in this case, it's 52.65, and our HG equals 250.85. So we put these values in this formula. So our H equals our HF, which is 52.65, plus our X, which is 0.009318, times the difference between Hg minus Hf. So it's 250.85 minus 52.65. So our H equals, this is our enthalpy, equals 52.65 plus 0.0093 times this equals 54.49. So our enthalpy, we have to multiply it times the mass, which in this case is 10. So our enthalpy from the A part, it's 544.9. And now for part 2, we have that this is kilojoules. For part 2, we have that in the problem it states that it's 600 kilopascals. So we have to look for the values in the table A12, but in this case we already have these values because the 600 kilopascals are in these tables. So our BF equals, in this case, 0.0008198. This is cubic meters over kilograms, and our Bg equals 0.034335 cubic meters over kilograms. So we have to compare it to this value. So this value is also in between these two. So we have to calculate our x. So our x is B1 minus BF over Bg. In this case, our B1 is 0.0014 minus our BF, which is 0.008198 over the difference, 0.034335 minus 0.0008198. So our x equals 0.00 minus 0.0008198. So the x equals 0.0173. So with this x, we can calculate the enthalpy. So we have that the formula is H2 in this case equals HF plus X times HFG. These values of enthalpy, we have it in the tables. So H2 equals our HF, which is 81.5 plus our x, that is 0.073, times the HFG, which in this case is HFG 180.95. So our H2 equals 84.73, but we have to multiply it times the mass. So our enthalpy equals 846 kilojoules. And for this case, the temperature equals our Tsat. So in the tables we can locate the value. So our temperature equals 21.55 Celsius. So that's it.